Most recent information from the James Webb Space Telescope has tracked down proof of a past with life structures on this planet. Yet, that is not all. Mercury might be different from what we figured it could be. Things that have been directly before our eyes from the beginning, we simply haven't seen. Investigating Mercury is thought of as nearly impossible and perilous, and for good reason, which we now understand. Hidden in the actual focus of our solar system is a planet that hardly anyone has considered with regards to an awesome revelation. Based on recent observations in which the James Webb Space Telescope was utilized, researchers suspect that Mercury has a secret it has kept well hidden from us until now. Mercury is a rocky planet, somewhat larger than our moon and significantly smaller than Earth or Mars. This world was thought to be too hot to hold on to life or any sort of water. However, analysts then discovered water deposits on Mercury, and our picture of this world is changing dramatically. Perhaps we need to completely reconsider our understanding of the solar system. Mercury isn't the intensely hot world you might expect. While Mercury is the closest planet to the Sun, being just 58 million kilometers away compared to Earth's 150 million kilometers, it's not the hottest planet in the solar system. That title belongs to Venus. Despite Mercury's proximity to the Sun, its atmosphere is so thin that the planet experiences extreme temperature fluctuations, heating up to 427 degrees Celsius during the day but dropping to around minus 173 degrees Celsius at night. This dramatic temperature range is due to Mercury's lack of a significant atmosphere to store heat. Unlike Venus, which has a dense atmosphere that traps heat and creates a runaway greenhouse effect, Mercury's surface cools rapidly once the sun sets. Mercury's surface is marked by a varied landscape with numerous craters that tell the story of its geological history. Some of these features include vast plains that were likely shaped by ancient volcanic activity, and cliffs known as lobate scarps, which are hundreds of kilometers long and up to 3 kilometers high, indicating that the planet's mantle has contracted as it cooled. Interestingly, Mercury's poles are home to craters that are permanently shadowed, keeping them cold enough to store water ice. A discovery that has surprised scientists who long believed the planet was too hot to sustain any form of water. This revelation has led to new questions about the planet's history. Could Mercury, once considered an uninhabitable world, have been in a different position in the solar system, possibly within the habitable zone? Some researchers suggest that Mercury might have been pushed closer to the Sun by Jupiter's gravity. The James Webb Space Telescope is set to provide new insights into Mercury's mysteries. With its advanced imaging capabilities, the telescope will be able to analyze Mercury's surface and atmosphere, potentially uncovering more secrets about this planet's past and its capacity to support life. If further evidence of water or other volatile compounds is found, it could dramatically change our understanding of Mercury and the solar system as a whole. Mercury's position in the solar system makes it a particularly intriguing target for exploration. Its proximity to the Sun presents unique challenges for observation and study, but it also offers opportunities to learn more about the dynamics of planetary formation and evolution under extreme conditions. In terms of its orbital characteristics, Mercury travels at a remarkable speed of about 47 kilometers per second, completing a full orbit around the Sun in just 88 Earth days. This rapid motion, combined with its slow rotation on its axis, results in unusual day-night cycles and solar exposure patterns, which have fascinated astronomers for centuries. The challenges of studying Mercury have led to relatively few missions to the planet. The Mariner 10 mission in the 1970s provided the first close-up images of Mercury's surface, revealing its cratered terrain and geological diversity. Subsequent missions, such as Messenger, Mercury Surface, Space Environment, Geochemistry, and Ranging, further enhanced our understanding by mapping the planet's surface in detail, studying its magnetic field, and analyzing its exosphere, a thin layer of gases surrounding the planet. The James Webb Space Telescope, JWST, promises to revolutionize our understanding of Mercury. Equipped with advanced imaging and spectroscopic tools, JWST will allow scientists to study Mercury's surface composition with unprecedented precision. By observing Mercury as it transits across the Sun, JWST will analyze the planet's atmosphere and surface features, providing new insights into its geological history and potential for harboring water or other volatile compounds. These observations could help answer long-standing questions about Mercury's formation and evolution. For instance, understanding the distribution of water ice in permanently shadowed craters could shed light on the sources and preservation of water in the inner solar system. Additionally, studying Mercury's exosphere and magnetic field could reveal more about the planet's interaction with the solar wind, a stream of charged particles emanating from the Sun. If JWST's findings confirm the presence of water ice or other interesting compounds on Mercury, it would have significant implications for our understanding of the planet. Such discoveries could suggest that Mercury is more dynamic than previously thought, with processes that might be more similar to those on Earth or Mars than we have assumed. It could also raise the possibility that Mercury, despite its extreme environment, might have once had conditions favorable for life, if only briefly or in isolated regions. The idea that Mercury could hold more secrets than we currently know is a tantalizing one. As one of the least explored planets in our solar system, it offers a unique opportunity for discovery. The James Webb Space Telescope, with its powerful instruments, is set to uncover more about this mysterious world, potentially rewriting the history of our solar system. As we await the results from JWST, the scientific community is abuzz with anticipation. What new discoveries will we make about this small, rocky planet that orbits so close to the Sun? Could Mercury's history be more complex than we ever imagined? These questions, once the domain of speculation, may soon have answers that could change how we view not just Mercury, but our place in the solar system as a whole. As we delve deeper into Mercury's mysteries, it's worth reflecting on how this small planet fits into the broader narrative of planetary science. For many years, Mercury was overshadowed by its more prominent neighbors like Venus and Mars, which were considered more likely candidates for exploration due to their larger sizes and more Earth-like conditions. However, recent findings and technological advancements, particularly with the James Webb Space Telescope, JWST, have sparked renewed interest in this enigmatic world. One of the key areas of focus for JWST's observations will be Mercury's geological activity. Despite its small size, Mercury shows evidence of a surprisingly dynamic past. The planet's surface is marked by vast volcanic plains, towering cliffs, and massive impact basins, such as the Caloris Basin, which stretches over 1,500 kilometers in diameter. These features suggest that Mercury has undergone significant geological changes over billions of years. The discovery of water ice in Mercury's polar craters has added another layer of intrigue. Water is a crucial ingredient for life as we know it, and its presence on Mercury, even in frozen form, challenges our previous assumptions about the planet's ability to host life-sustaining environments. The question now is whether there are other volatile compounds on Mercury that could further hint at the planet's past potential for habitability. Mercury's magnetic field, another fascinating aspect of the planet, will also be a subject of detailed study. Unlike most other terrestrial planets, Mercury has a magnetic field, though it is much weaker than Earth's. This magnetic field, generated by the planet's partially molten core, interacts with the solar wind, creating a magnetosphere that helps shield the planet from some of the Sun's harsh radiation. Understanding how Mercury's magnetic field operates could provide valuable insights into the planet's internal structure and the processes that drive its geological activity. Another area of interest is Mercury's exosphere, the thin layer of gases that surrounds the planet. Mercury's exosphere is primarily composed of hydrogen, helium, oxygen, sodium, and potassium. Unlike a traditional atmosphere, the exosphere is not thick enough to support weather systems or trap heat, which contributes to the planet's extreme temperature variations. JWST's spectroscopic capabilities will allow scientists to study the composition and dynamics of Mercury's exosphere in greater detail, revealing how it is influenced by the planet's proximity to the Sun and its interactions with the solar wind. The potential for future missions to Mercury is also on the horizon. While the challenges of exploring such a hot and inhospitable world are significant, the scientific rewards could be immense. New missions could be designed to land on the planet's surface, drill into its crust, and bring back samples for analysis on Earth. These missions could help us determine the age of Mercury's surface features, the composition of its rocks and soils, and the history of its magnetic field. As we consider the future of Mercury exploration, It's important to remember that every new discovery about this planet has the potential to reshape our understanding of the solar system. Mercury, once thought to be a relatively simple and unremarkable world, is now recognized as a complex and dynamic planet with a rich geological history. The findings from JWST and future missions could provide crucial clues about the processes that shaped not only Mercury but also the other rocky planets, including Earth. In conclusion, Mercury is a planet full of surprises. Its proximity to the Sun, its extreme temperatures, its unique geological features, and its unexpected reserves of water ice all make it a fascinating target for scientific study. The James Webb Space Telescope promises to unlock new secrets about Mercury, offering us a deeper understanding of this small but significant world. As we continue to explore Mercury and its mysteries, we are reminded of the vastness and complexity of our solar system and the endless possibilities for discovery that lie ahead.